Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of limits. And if I talk about the question which is given to us here, the question tells us that let x in the square bracket denote greatest integer function. Means we are finding the greatest integer which is less than or equal to x. Further, we have been told f of x is maximum value of three functions are given to me in that. One is 1 plus x in the square bracket, that is greatest integer function. The second is given to us as just 2 plus x. And the third it is given to us as x plus 2 times of x inside the square bracket. That is again your greatest integer function. We have been told that this f of x goes for all the values from x equal to 0 to x equal to 2. So if I want to denote it in the terms of my brackets, I can always denote x since it is equal to 0. I am showing it in terms of a closed interval, and 2 also it is equal to, so I'm just showing it in terms of a closed interval. So x basically lies from 0 to 2. Further, they have told us m, it indicates number of points in 0, 2 within the square brackets. So basically for all the values of x from 0 till 2 means you are equating x with 0 also and x equal to 2 as well. And further they have told us this m is number of points in this interval where f is not continuous. And further we have been told n is again number of points in the interval from 0 to 2. But here we have been given open interval, which means x is between 0 and 2. It is not equal to 0 and not equal to 2. And here we have been told where f is not differentiable. So we need to find number of points in this intervals given where f is the function f of x is not continuous and not differentiable. Once we find m and n, then they have asked us to find the value of m plus n the whole square plus 2. So we have been asked to find the value of this entire expression. And if I talk about the options which is given to us here, the options are A3, B6, C2, and the last option given to us is A. So we need to figure out which one of the following four options is the correct answer for the question given to us. Let's solve this idea. So if I see, I know since it is given to us a greatest integer function for all the values of x from 0 but less than 1, we will have the greatest integer function's value turning out to become 0, because we know greatest integer function is the value of the greatest integer that is less than or equal to x. So the greatest integer less than or equal to in this condition becomes 0. If I have values of x from 1 and less than 2, value of the greatest integer function becomes equal to 1. And for x equal to 2, which is the last value, the value of the greatest integer function becomes 0. So let's figure out all the three functions so that we get f of x, which is maximum of all the three functions. So first, if I write it down, first function 1 plus x within the square brackets. So we have three intervals. Let's figure out, let's say this is a function, any random function, let's say g of x. So g of x, let's see what it becomes. When you have x interval from 0 but not equal to 1, less than 1. So basically I'll show it by an open interval. Then from x equal to 1 till 2, not equal to 2, just less than 2, and for x equal. So basically x belongs to this, x belongs to this, and in the third part we'll put x equal. Let's see what our function becomes. So what I get from this is 1 plus x plus for the intervals from 0 less than 1, we had the greatest integer function value is 0. So 1 plus x plus 0. So 1 plus 0 is 1. So you get 1 plus x. Second, for this interval, we have the greatest integer function's value as 1. So if I put here 1, 1 plus 1 plus x, so 2 plus x. And here if I put x equal to 2 directly, 1 plus 2, 3, and 3 plus 2, 5. I get this value as 5. So this is your values of g of x. Let's see the other function. So if I see the other function that is given to me, 2 plus x, so it is not dependent on the greatest integer function. So for all the values from x equal to 0 to x equal to 2, we have, let's say, this value, this expression or the function as 2 plus x. And let's say this is nothing but r of x. So r of x, I understand it is equal to 2 plus x for all the intervals where x belongs to 0 till less than 1, where x belongs to 1 less than 2, and when x equals to. So when x equals to 2, I get this 2 plus x turning out to become 2 plus 2. So we get this idea. And the third, if I see the third function given to me, which is x plus 2 times in the bracket greatest integer function. So x plus 2 times the greatest integer function. Again, if I put that, let's say any other function, let's say h of x. So what does your h of x become now? So if I put the values of x first from 0 but less than 1, values of x from 1 but less than 2, and the values of x equal to 2. Let's see what our h of x becomes. So you get from this x plus 2 into this is 0. So x plus 0, which turns it to become just x. So this is your function. Next, if I see x plus 2 times, here we have the greatest integer function as 1. So x plus 2 or 2 plus x, it is the same thing. And here we have for x equal to 2, if I put this 2 plus 2 times 2, so that is again 6. So we get this values. Now let's combine all of them to get our function. So we have been told function f of x is maximum of all these functions. That was g of x, r of x, and h of x for the intervals from 0 to. So if I try to find out f of x from 0 till the values of x less than 1, where x belongs to closed interval of 0 and open interval of 1. If I try to find the maximum of all these functions from this, here you have x, here you have x plus 2, here you have x plus 1. So maximum I can see is x plus 2. So here I have x plus 2 as my function f of x. Further, if I try to see in the next interval where x is equal to 1 but less than 2, here if I try to find out, you have x plus 2, x plus 2, x plus 2. All of them are the same functions. So your maximum also becomes the same function, x plus 2. And the third, if I try to find out when x is equal to 2, the maximum value, if I see for x equal to 2, it is 6. So this becomes the maximum. So you get f of x as 6 for this interval. If I see for this interval as well as for this interval, you have the same function x plus 2. So if I try to simplify my function f of x, I understand it is x plus 2 when your values of x are from 0, but the values of x are less than 2. So from 0 till the values of x less than 2, you have function f of x as x plus 2, and for x equal to 2, you have it as 6. So this are your functions f of x. Now here if I try to see the continuity first, it's telling me m is number of points in the closed interval where x goes from 0 to 2, where function is not continuous. So I understand from f of x equal to 0 up till 2, or the values of x just less than 2, you have the function x plus 2, which is continuous. If I put x equal to 2 and x equal to 2, if I put this value of x as 2, I get 2 plus 2, 4. But here it is 6. So I understand that x equal to 2, f of x is not continuous. So I get only at x equal to 2 f of x is not continuous. So the number of points where function f of x is not continuous in the interval from 0 till 2, I get m is 1 because there is only one point where the function is not continuous, and that is at x. So I get the value of m as 1. If we talk about n we have been given that it is number of points where function is not differentiable, but they have asked us to find the number of points in the open interval of 0 to 2. So open interval, if I understand, it is x greater than 0 and less than 2, where the function is not differentiable. They have asked us to find how many points are there. If I see the previous function f of x, I understand from x greater than 0 and less than 2, we have the same function x plus 2. So it is differentiable at all the points. So n in this case becomes 0 because there are no points where the function is not differentiable in this interval given to us. So we get n as 0. If I just figure out the value of the expression that is asked to us, m plus n the whole square plus 2. So here if I see m is 1, n is 0. So if I put that points, 1 plus 0 the whole square plus 2. So 1 square 1 plus 2, that is 3. So I get the answer for the expression as 3. And if you see the option that matches here with the question, the option is A. So A is the correct answer for the question given to us. I hope you have understood how to solve this type of questions which deals with the ideas of greatest integer function applied with the limits. So we just found out the greatest integer functions for all the intervals. We put that in the three functions. We found out the maximum values for the three different intervals to get f of x. Once we found that out, we found f of x is same for the two intervals. So we merged those two intervals and we simplified our f of x as this way. Then we found out that it is not continuous in the closed interval of x equal to 0 to 2 at only one point, that is at x equal to 2. So m is equal to 1. And it is differentiable at all the points for this open interval given where x is greater than 0 and less than 2. So we get there are no points where f of x is not differentiable. So you get m as 1, you get n as 0. If you put that in your expressions value, you get the answer as 3 that matches with option B. So A is the correct answer for the question given to us. I hope you have understood how to solve this type of questions. I will see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on 11th, 12th as well as geometry mains. So stay tuned for more videos to roll out. Also, do like, share and subscribe to my channel. Do share these videos with your friends also who are involved in the preparation of the questions on GWA mains. So they can take also the benefit from these questions which we are solving on a daily basis. Thank you.